This example goes through a three-legged OAuth 2 flow, often abbreviated 3LO, using the Todoist API. OAuth 2 is built on top of the transport layer security, or TLS protocol. This allows us as application-level developers to minimize our exposure to writing our own security code, as most of it is baked into TLS, which is used by HTTPS. As TLS improves, we get those benefits automatically. For OAuth 2, there are two widely used models: client credential, which does not include the involvement of user resources. The Spotify album art project is an example of this. The other model that we'll be looking at in this example is the three-legged model. Three-legged OAuth 2 is used when we want to interact with resources that are user-specific. Resources, in this case, are a generic term for a particular user's personal data in relationship to the API. For example, when using the Spotify API, one possible resource could be playlists. Spotify's API allows applications to interact with a particular user's playlists, which includes looking at track details, adding new tracks, or removing tracks, but only if the user has explicitly granted the application permission. In the example covered here, we will be using the Todoist API. Todoist is an API that allows users to create personal to-do lists. And our API will interact with an individual user's to-do lists, in this case, creating a new task. You can imagine the chaos that would happen if anyone could write a program that could interact with everybody's to-do list without their consent. From an API designer's perspective, applications should only be able to access a user's resources if they have explicitly granted it. This creates a technical challenge, as the permission can only be granted when the user is directly communicating with the API, as opposed to through a middleman like our server. But in order to deliver content to the user, we need to be directly communicating with them. And HTTP only supports communication between two entities and not three. External applications should not be prompting the user for their account credentials, as this becomes a major security hazard. This is where three-legged OAuth comes into play. Three-legged OAuth 2 is a trust exchange framework that involves three entities: the resource owner, also called the user, the API where all resources live, and the third-party application that wants to interact with the user's resources. This example uses the Todoist API. Our goal is to add a new item to the user's to-do list. In the browser right now, we have the Todoist dashboard, where we can manually create a task. But our goal is to write a program to do this. Our first step is to generate the client ID and secret pair, as well as introduce the concept of the OAuth redirect URL used in three-legged scenarios. We can do this from the Todoist Manage app page hosted on developers.todoist.com. Over here, I've created a sample application. On this page, we have the three values that we care about: client ID, client secrets, and OAuth redirect URL. Client ID identifies my application, but client ID is exposed to anyone who uses my application. Anyone can see it, so it cannot be used for authentication purposes. Otherwise, a malicious application could copy that client ID and make requests on behalf of my app. To prove that we own the specified client ID, we have a client secret acting as a password field. It's important that you generate your own client ID and secret pair, as the ones that I'll be using in this example will be resetted after the video has been recorded. But the client secret should always be guarded and only be sent to the API via HTTPS. Finally, after the user has granted their permission to an application, the redirect URL specifies where to redirect the user and their proof of granted permission to. We set this to be localhost 3000 receive code. Three-legged OAuth 2 uses browser redirect commands to send the user to the API authentication server, where they log in and grant our application permission to use their accounts. This same redirect command is then used to forward the client back to our application, and the OAuth redirect URL over here specifies the endpoint to redirect them to. Before going into the code, we use a sequence diagram to illustrate how three-legged OAuth 2 looks from a high-level view, as there are many required steps. In this sequence diagram, it may look like we have 4 entities, but it's only 3. This is to avoid overlapping lines, a limitation of 2D diagrams, which I feel create a false perception that the data is flowing through a middleman. This interaction begins with a user who sends a request to our server for the root of the site. We deliver a HTML form for them to fill out, where we capture a single input task. The server saves the task into an array task states indexed by a randomly generated key called the state. We respond to the client using a 302 redirect. 302 is a status code for temporary redirects. When the browser receives this, it sends off a new request to the location specified by the header's location. The scope, which tells the API what permissions our application is requesting, and the state variable, which it will return to us unchanged, so that we can identify the originating request and all data associated with it. These three pieces of data are supplied by embedding the values into the redirect URL via query parameters. The URL in this case is todoist.com/OAuth/authorize, followed by a query string including the client ID, scope, and state. A 302 redirect including all of this information is sent to the client. Once received, the browser finishes the current request and opens a new one up with the redirect URL. At this point, the browser finishes the current request and opens a new one up with the redirect URL. The user is now directly communicating with the API's authentication servers and can log in safely without our application's involvement. Once logged in, the API will prompt the user with the list of scopes that our application is requesting and whether or not they accept the release of these permissions. For simplicity of this diagram, we will assume that they do. After logging the user's explicit grant permission, the API sends a 302 redirect back to our server using the OAuth redirect URL that we specified initially. Attached to this are two pieces of data encoded using the query string format. Code, which is the representation of the user's explicit permission to grant a given client ID permission to access specific scopes for their personal account. And state, which is the same value that was originally received. In this case, we use state to look up the original task from the array task states that was originally submitted in the first request. Because of the 302 redirect, the browser will finish the request with the Todoist endpoint and opens a new one up with the redirector URL, effectively forwarding these two values back to our application server. Once arrived, our application server's next step is to send the API two key pieces of information before we can interact with the user's accounts. Proof of the user's explicit permission to interact with their account, which is the code, and proof that our application owns the specified client ID, which is our client secrets. Because we send the client ID to anyone who wants to initiate an OAuth connection, we cannot use this for authentication. What we use instead to prove our ownership of the client ID is the client secret. These two values are supplied to you when you create an application. The client ID identifies your application, think username, and the client secret proves the ownership of the client ID, think password. The client secret should never be sent to any users. Instead, when we have a secure connection with the API, we provide the code, client ID, and client secret in order to 1. Prove that the user has given their explicit permission to have a specified client ID interact with their account governed by the scope clause. And 2. Prove that our application owns that client ID by supplying the client secret. The API will then check to make sure these values are still valid, and if everything checks out, the API will return an access token, which allows our application to use the API and interact with the user's resources as long as that access token remains valid. That ends the three-legged OAuth flow. From this point on, the application includes the access token inside of the headers each time it wants to interact with the user's resources. In our application, we send a post request to the endpoint REST v1 tasks in order to create a new task modalon according to the API's specifications. We get back a response with some metadata, including a URL which points to the permalink of the created task. Our application then sends one last 302 redirect to the user, redirecting them to the results. Next, let's perform the required network request using Insomnia. Our server first sends a 302 redirect to the client. The URL for this redirect specifies three values: client ID, scope, and state. All three of these are supplied by query parameters. When sending this request to the Todoist API, it prompts us to log in. I'm going to copy the URL preview into a real browser so that I can log in. This will prompt me to log in if I'm not logged in already. Then it will prompt me to grant permissions if I haven't done so already. Lastly, it will send a 302 redirect to the OAuth 2 redirect URL. In this scenario, that was specified to be localhost 3000/receive code, which we have over here. Since we haven't launched our server yet, this request fails, but the URL contains a query string that we can continue to use manually. There's a state variable which we will use to tie the current request back to the previous one that finished with a 302 being sent to the client. And there is a code which represents the user's explicit permission for a given client ID. I'm going to copy this value. The next step involves getting the access token by trading in the code, client ID, and client secrets. The reason this step is necessary is that our application needs to prove that it owns the client ID, and since we give the client ID to everyone who tries to use our app, that value must be considered public. Someone else could build an application and try to use the same client ID. The client secret, which should never be disclosed to anyone but the API, protects our application's identity. For the Todoist API, there are three values sent to the OAuth access token endpoint using the post method. These are sent using the query string formats. The three values that we're going to include are client ID, client secret, and code. We exchange these three values for an access token. Finally, the last step has us creating a task. The Todoist API wants us to post to the endpoints REST v1 task, a JSON object representing the task to create, with the access token in the headers. In addition, we also have a content type application/JSON, which describes the body of our message. The task that we are trying to create in this scenario has the title sample task 123. When this request is sent off from Insomnia, expect a new task to be created from within the Todoist application. The task was added to our to-do lists. We also get a JSON response back from the API, which includes a URL property, which our application can extract, and send a final 302 redirect to the client, taking the user to the created task. So this would be what the user would see. Finally, we'll look at the code. We add the crypto library to generate a random key to be used for the state variable. Recall that the user first fills out the form, then we redirect them to the API to generate the code. We need some tool to tie their later requests when they return back from the receive code endpoints with the original request that included the user inputs. This is because HTTP does not have any built-in mechanisms to remember that a user has made a previous request. To add this functionality, we generate a unique key to the user after they've submitted the form called state. We store any data that the client has generated into an array, task states in this example, and use the variable state as the index to this data. This index is created by using the crypto package's random bytes method. The state is passed to the clients, whom will eventually return it to us, where we can use it to look up their previous variables. This technique is commonly called creating a session. If the user visits the root of our site, they will be presented with a HTML form with a single input task representing the task that they want to create on Todoists. When this form is submitted, the data goes to an endpoint add task, which catches the request and extracts the user inputs and stores it into a variable task. Next, we use the crypto package's random bytes method to generate a key called state used to index each of the tasks. We generate an object pair task, state, which we will use to temporarily store the user's input. This data is put into the array task states. We will retrieve it when the user returns back via the receive code endpoint. Redirect to Todoist sends a 302 redirect to the Todoist authorization endpoint to let our users log in and grant our application permission. The redirected URI includes client ID, scope, and state. Once logged in and permission is granted, the Todoist API will send a 302 redirect to return us to the endpoint receive code. Using the state as the key, we look up the previous task variable from inside the array task states, and then forward the three results code, task, and response to a function send access token requests. This function has us exchanging client ID, client secret, and code for the access token. This data follows the example in Insomnia and is supplied as a query string using a post request. As we get the results, we feed it through a function process stream to convert the stream type into a string before calling the function received access token. Upon receiving the access token, we parse it and the three-legged OAuth flow is finished. We can now interact with this particular user's resources using the access token for authentication. The demo next calls a function send add task requests in order to create the task. This function sends a post request to the REST v1 task endpoints. The post data includes the task that we want to create. The method and the headers follows the same format as in Insomnia, and includes the access token in the authorization field, prefixed with the keyword bearer. We send this request off, and upon receiving a response, convert it to a string again using the same process stream function, and then parse the results. The results object contains a URL property for the created Todoist record. Our application then sends one final 302 redirect to take the user to that item. Next, let's run this. So our server is up and running. We're going to add a task, hello world. Our server redirects us to the Todoist API to log in. Our application redirects us to the Todoist API, and if we were not logged in, it would prompt us to log in, followed by a prompt to grant permissions if we haven't done so already. When I click agree, it should redirect back to our server application, which will create the task, and then redirect us back to the Todoist application to display the created task. As you can see, we have created a new task, hello world. If I go back to the first results, and I try to create another new task, because I've explicitly granted flow already, this flow is short-circuited and should be much quicker the second time. Notice there were no prompts at all. The last video will have us combining the GitHub Jobs API with the Todoist API